Investigation 12.1, first lab of the new year, semester rather, quarter three. This is a pretty good one because it has students kind of doing a lot of exploratory parts of electric circuits and diagrams. It is quite lengthy, so this might be one that you break up into a couple parts. I think a good break would be when you get to part 8 and 9, you actually switch over to doing current versus voltage. So you might want to spend one day covering voltage and then the other they can explore current and kind of mix and match it up. But I'll leave that up to you guys. Starts off pretty basic. Students get to look at the light bulb. They have to draw a diagram larger than this. It does say that in the instructions to kind of show the different components that are in a light bulb. Then they're challenged. You're given the battery, 2 wires, and a light bulb, and you have to figure out how to light it up. And so now students might be a little nervous at first. They're going to get shocked. These batteries do not carry enough voltage to do any of that. So they should connect up the wires on either side of the battery. One of the wires needs to touch the side of the light bulb. This might be good to do with partners because I'm finding it difficult with my hands. And then the other needs to touch the bottom of the light bulb. So you should see, hopefully there in camera, it's lighting up. And so that's one thing most people don't realize, that the current, there's this separation where current is coming either through the top into the bulb and then out the side, or vice versa. So that's kind of a neat feature for them to learn. And then they're also challenged next, hey, can you do that with one wire? So now they're just challenged with one wire. Easiest way to do that would be to hold the bottom on side of the battery, and you might actually need to give them a blue wire, maybe give each a blue and a green, and then connect from one end of the battery to the side of the light bulb. And again, partners, probably beneficial for this, but if I get it situated in my palm, I can get it lit up with just one wire, as long as the bottom of the bulb is touching the battery. So the first part's not too complicated, but it's kind of showing them, hey, circuits don't need to have this complex board. You just need a pathway for the electrons to move, and it kind of helps them see exactly how the electricity is flowing through the light bulb. And then I pre-built this, but then I asked them, we're gonna build a simple circuit. You got a battery, a switch, and a bulb. It gives them the photo to build it based off of, and then it's gonna ask them a bunch of questions about the actual circuit. You should see that as you close it. Now with one battery, it's not gonna be super bright, but that's just to do it that way. They can see it glowing. I hope it comes up on camera, but they can interact with that to help answer all the questions. And then they're just gonna quickly modify their circuit such that there is a gap in the circuit. So here, my switch is closed, light bulb's not on because, excuse me, because there is a gap here. And then they're gonna be given a variety of materials. So I brought in a variety of materials, some of them which says it was listed, some I just kind of found lying around. Just make sure that you have at least one conductor or two in the mix of materials, because what they're going to be doing is classifying these items as either conductors or insulators. So paperclip, for example, if I expand it and I connect it to either side, you can see the light bulb now turns on, and I'm using the paperclip to connect that. That's not the same. Oh, that toothpick is too short, but let's say a Q-tip. My Q-tip touching both sides, nothing. I got glass, nothing. I grabbed a penny, but that's not big enough. I did grab copper wire. Yep, so this is not insulated. If it's insulated, it won't work. But that connection works. I can even use the copper wire to help the penny out. Now, penny's made of copper, so that should still work, although it is quite oxidized. So actually, yep, there we go, it does work. And so the penny is conductive as well. So you can use tricks like that to kind of help spread that along. Next is going to introduce the idea of symbols for students. So they're going to draw that simple circuit using the symbols. This you might want to do together as a class because they wouldn't know. The default is like kind of keep it in a box shape. If a student looks at this and tries to draw it, they might draw a circle. It's just easier to draw circuits with neat little corners. That was something I always had to teach the students. That might actually be a good stop for the first day, because the next half of the lab, students are actually going to be using the multimeter. And these, they can be complex because you have to have these set to the right spot. And so you might want to be in charge of that. If students have it set to the wrong thing, they could break the circuit, cause an issue, and then a light bulb might blow. I've had that happen when I first started teaching way long ago. But first they're going to be measuring voltages. So this is a different multimeter than was probably in your schools. But if you switch it over to the 20 volts, that should give you a good measurement. We're just going to start off with the basic battery. And these big D-cell batteries should be reading somewhere at 1.5. It has them investigate with 2 batteries, changing the different sides that they're measuring on. So they should see, hey, it was negative 1.5, now it's positive 1.5. So it's measuring the exact flow of the current. They should experiment with 2 batteries going in the same direction. What does that do to my total voltage? So if I connect it, now I'm up to 3. So it's doubled. It's kind of additive. But if you reverse those and try to measure them against each other, you'll notice that they cancel, and I'm left with 0. And so they're just kind of experimenting with how batteries can work in conjunction with each other, measuring voltages. It's actually pretty simple. And then they can actually experiment doing that across the circuit. And so they should see, okay, it's set up in a circuit. Hey, I'm still getting 1.5 volts, just like I did with the battery. What happens if I close the circuit? Now what's my voltage? They might think that it changes. Actually, you do need, so they would measure here and they'd see 0. But if you actually measure across where the light bulb is at, you get the 1.5 volts. And so that's kind of something that they need to learn, is that the voltage is changing across where that energy is being used up. All right, so I'm not going to go over the next part. It adds in the potentiometer or the dimmer switch, and then they can kind of see how that changes the voltage. They just collect some data, and get some quantitative and qualitative data. And then it ends with them measuring current. With current, I'll try to show you, but you do need to switch this over onto the amp side. And I went to the 200 milliamps. You want your circuit to be turned off when you're measuring current, because what this is doing when it measures current is actually passing the current through the device to measure it. So if you have it turned on and then you measure current, you're going to create a short circuit that's going to cause issues with your light bulb. So have it turned off, and you'll notice that when I measure the current, it actually finishes it, turns the light bulb on, and I'm measuring at, less negative, but 58 milliamps. And they can use that to collect the data to finish off the lab. So you can see how this can get, it's kind of exploratory, then it gets a bit complex. So it's breaking that up into 2 sections. Maybe the second day they're using the multimeters to measure the voltage, current, get used to all that sort of stuff. Experimenting with these, finding other objects in the classroom will probably be good. But that's a great start into the unit on electricity. Don't let these scare you. Just get your hands on them. Same with the students. Get them investigating, and helps them visualize currents. So I will see you guys in the next video.